but thanks everyone for attending. So quick intro, actually, Christina, hello. I know you from before, but my name is John O'Donnell. I'm a principal solution architect here at AWS. Been here for over a little bit over about 7 years now, and we've done a realignment. I think we covered that last time, but essentially now we're focusing on the industry verticals in the healthcare life sciences, particularly specializing in providers on the healthcare side. So go to the next slide. So again, a lot of this will be kind of overview, and frankly, Tony's got the really amazing presentation, so I won't take too much of his time. But machine learning, AI/ML, generative AI is mainstream today. I'm not telling you something you don't already know. But again, 100,000 plus. That number's probably we're always very conservative here with AWS, but customers are using our services. If you kind of come from I would say the quote unquote old days, SageMaker, some of the more fit for purpose engines that we had to now where we have Bedrock, and I'll kind of cover those. But everyone at AWS is using this, and really it's a fascinating how fast this is moving is stunning, to be honest. So just a level set before we jump in, what is there's AI, there's machine learning, there's generative AI, there's all sorts of flavors there of each, right? Artificial intelligence started actually in the 50s, right? If you're a coder, it's basically glorified if-then-else type of statements for machine learning, where computers basically mimic so tic-tac-toe, for example, leverages artificial intelligence, so it beats you every single time in chess, for example. It's very programmatic for that. And then machine learning is the subset that actually will look at data, and there's labeled and unlabeled data, but we won't go into that. But where it's going to discover patterns in your data and build models automatically. And again, I've worked in financial services industry, healthcare, life sciences, leveraging this. This is real world stuff that's being used today. And then deep learning is a very specific, what's called neural networks. So speech recognition, speech generation, image recognition uses deep learning. Familiar with Tesla's kind of the automated cars, right? Reinforcement learning is another kind of flavor of that, where the model makes a mistake, it gets a penalty. If it makes a right move, it gets a reward. So deep learning is really deep into there. And a lot of the kind of the fit for purpose services that we have at AWS, Textract, et cetera, are leveraging that model. And kind of like the quote unquote new things, since ChatGPT kind of really blew the world, but just kind of changed the world, frankly, not too long ago, is generative AI. So basically, this is just almost you're shoving the entire internet, training a model on it, vast corpus of data, and leveraging what's called a foundation model. So what is generative AI, for us, right? It basically can create original content. You can write blogs or articles or summarization. There's any number of tasks. And Tony's actually going to show some real world use cases where generative AI is really just an amazing fit versus more programmatic type of coding for that. It's trained against billions and billions of data points, right? So if you think about like what's behind a foundation model, what's behind generative AI, it's say the entire internet, but a fair portion of the internet, right? And that's why it's so expensive to kind of build models. And what I'm hearing is in the hundreds of millions of dollars for each. When you hear about like Claude Opus, for example, that's in very high 9-figure type of numbers as far as costs. Again, a lot of these you've seen. There's minimal fine tuning, so you don't have to be a data scientist to leverage these models. So why would you use foundation models? As I explained a little bit earlier, is fit for purpose, traditional ML. I mean, we're really dating ourselves, right? That this was cutting edge. This is still cutting edge stuff, right? But I have a really good, say, summarization engine. That's all it does, right? I take labeled data, I curate the data, I apply a model to it, and I come up with a very task-specific thing. So AWS Textract, for example, will do kind of read text, convert it into text, tables, columns, things like that. It's all it does, but it's really, really good at that, right? Poly, for example, will take existing text and build audio from it. It's all it does, but it's really good at that. But it's a iterative process, and you have to know how to assemble all the pieces together. Where foundation models, right, is I'm just literally shoveling what's called unlabeled data. So that's unstructured data. Every big company, everyone that's on the call today, on the line and the recording, if you're working in a company, you got 80, 90% of your data is probably unlabeled, unstructured data, right? Very little of it is labeled data, right? So this is kind of like text documents, PDFs, et cetera, right? That's ingested by a foundation model, where the foundation model is very good at adapting and doing multiple tasks. So that's the difference between, if you're familiar with traditional machine learning and a foundation model. So use cases, again, probably review for everyone. I mean, chat is like virtual assistant. I'm actually in Corpus Christi today. My flight was canceled yesterday because of the storms in Houston, and I chatted with the United Airlines chatbot to get rescheduled, and it was pretty good. So I was actually pretty impressed with it. It can do code generation. We have tools for that. So when I've actually was building some applications to leverage generative AI, I use generative AI to help me build code in Python, right? Tony's a way better coder than me, but I used it to actually build some really pretty decent code that ran very well. And again, other use cases, as you're seeing there. Search, for example, I think the next really big, huge thing for generative AI is search, right? Because search right now has, some limitations, but generative AI and search and kind of its using intelligence to classify results is really huge. So again, really quick, I'm not going to read through all these, but like generative AI use case, we're going to focus on kind of the beginning of, in the beginning of that, which is clinical studies, right? But, be able to summarize patient records into EHR. A doctor has to type things in. It's annoying. My personal doctor, I talk to him about this type of stuff. He says he spends half his day typing things into his EHR. Wouldn't it be great if he could do recording? There are tools to help from a recording perspective, but also summarizing that, being able to pull information out during conversations. Patient-friendly reports for patient engagement. A lot of times, most patients have no idea what's going on in their health, unfortunately, right? So be able to kind of generate a patient-friendly report to how they understand it, maybe in a different language, maybe in a different, type of, of language, a summarization of, for a child, right, versus an adult, right? So there's all sorts of use cases out there where this could work. Looking at research publications, they're long, they're very technical, and they're very detailed, right? Be able to kind of pull and extract those needles in the haystack out of some of those documents is really important. And again, I think just the ability to improve enterprise search, whether it's enterprise or internet, that's a really big thing. So you've probably heard of Bedrock. What is Amazon Bedrock? And Tony's going to show you kind of, again, a real world example of that. We came out with that not too long ago. It's frankly, it's a multi-model approach to generative AI. So it's frankly, again, I haven't coded in a long time. It's easy to code against. It's very performant. I can pick different models. I can just swap out endpoints, right, and start using a completely different model without having to sign up or do different things. Eventually, you'll see through Amazon Q that all of our applications are going to have generative AI power behind them, right? So started really with QuickSight and some other things, right? But they'd be able to actually just leverage an application and have generative AI help you through that process is going to really help. And if you want to, you can build your own foundation models, right? So I do work with the team that does Inferentia and Trainium, which is basically chipsets that have been designed only to do generative AI and machine learning, right? You can build your own models. And again, it's a managed service, so you don't have to rack and stack your own hardware. So again, how does it work? As I mentioned, easiest way to do it, it's basically API calls. Again, Tony will walk you through those. You can fine tune your models if you want to. So for example, in healthcare use cases, you might want to use your own nomenclature, right? If you're a research company, as Ron had mentioned, right? You might want to put some of those terminology in there, fine tune it for those use cases. Again, a managed service that does that. Many data sources, and then be able to leverage agents. That's the hot topic if you haven't heard. Leveraging agents to dynamically invoke APIs based on some questions that the user is asking, et cetera. So One of the use cases I'm working on with one of my clinical customers is basically a summarized interaction, and actually they're doing document generation for clinical studies. So this is an example. This is not the architecture necessarily that they're using, but just showing you that, you know, the Lego blocks, right, is that a doctor who's very busy, again, I work with hospital systems, I work with clinical research companies, a medical professional is very busy. It takes a long time to go through the documents, to go through the screens, the click, right? What they want to do is, you know, don't tell me how to build a clock, just tell me what time it is, right? This will help them accelerate their ability to provide care to a patient. Does it tell them what to do? Absolutely not. We're never saying that, but it's going to help guide them down that, guide them down the path, right? So, for example, the document assistant will be able to read things way more quickly, right? Could go through hundreds of pages in a second, right? Where it could take a physician or a medical professional much longer for that. So again, an example, you know, architecture here. So in summary, what's needed to succeed here? You know, it's basically, I work with a number of customers who are leveraging generative AI today. They're leveraging the different vendors, different tools that we have, right? I think really just kind of picking a use case that's important to you, a valuable, and maybe not the easiest one, but actually one that you can show some real value for. Really a challenge I've seen, and this is not just in this space, is knowing where your data is, right? Do you know where all your data is? Is it data lake? Is it somewhere else, right? So, you know, knowing that where that data is obviously critical important. It's the correct source of truth. That hasn't changed in 20, 30 years. And then assess your internal capabilities. Can you do this on your own? Or would you like to leverage us, a partner, to help you through that, right? I always recommend, unless you have a team of machine learning experts, you know, work with your vendor, work with partners that you have that have done this, get your sea legs, right? Get to know it, and then then you can build that capability. And for that, and again, proof of concepts, right? Build these out. You know, I always say 30 days or less, iterate, make a lot of mistakes, make a lot of, you know, right decisions. And then when you're there, scale, boom, right? You can go from 0 to 60 very quickly with what we have here. So with that, thank you. Again, Ron, thank you for the opportunity to present. And I'm going to hand this off to Tony, unless there's any questions.